Across the unfathomable tapestry of space-time, we perceive an elegant and reliable order. We see the graceful waltz of planets, choreographed by the invisible hand of gravity. We witness the unwavering journey of starlight across cosmic voids. We rely on the consistent hum of electromagnetism that powers our civilization. Our existence is built upon a profound faith in a set of universal statutes. We call them the laws of physics, the fundamental rule book of reality. These principles are our compass in the vast, dark ocean of the cosmos. They are the language in which the universe writes its epic story. But what if this rulebook is not absolute? What if, in the deepest recesses of existence, in places of unimaginable violence, and at scales of infinitesimal smallness, there are domains of exception? What if there are zones where the elegant mathematics of our reality shatters? These are the lawless territories of the universe. They are not merely undiscovered countries on the cosmic map. They represent the very edge of the map itself, where the ink of our understanding runs dry. Here, causality frays, space and time dissolve, and the very notion of a rule becomes meaningless. This is a journey into the heart of cosmic anarchy, a voyage to the places where the laws of physics, as we know them, do not apply. For centuries, our conception of the cosmos was one of magnificent clockwork precision. From the ancient Greeks, who saw celestial spheres turning in perfect harmony, to Isaac Newton, who unveiled the universal law of gravitation, humanity has sought and found a reassuring predictability in the heavens. Newton's universe was a grand, deterministic machine. If you knew the position and momentum of every particle, you could, in principle, predict the entire future of the cosmos. It was a comforting thought, a reality governed by steadfast, unbreakable statutes. The planets would continue their orbits, apples would always fall, and the celestial clock would tick on with metronomic reliability for all eternity. This Newtonian dream of perfect order dominated scientific thought for over 200 years. It painted a picture of a universe that was, at its core, comprehensible. Then, at the dawn of the 20th century, a young patent clerk in Bern, Switzerland, began to see cracks in this perfectly ordered facade. His name was Albert Einstein, and his ideas would not just amend the cosmic rulebook, they would rewrite it entirely. With his theory of general relativity, Einstein revealed something extraordinary. Space and time were not the static, unchanging backdrop Newton had envisioned. They were a dynamic interwoven fabric, space-time. This fabric could be bent, warped, and stretched by the presence of mass and energy. Gravity was no longer a mysterious force acting at a distance. It was the curvature of space-time itself. Planets were not being pulled by the sun. They were following the straightest possible path through a space-time warped by the sun's immense mass. Imagine a stretched rubber sheet. Placing a heavy bowling ball in the center creates a deep well. A marble rolled nearby will not be pulled by the ball, but will instead follow the curve created in the sheet, spiraling inward. This was Einstein's universe, elegant, geometric, and still, for the most part, predictable. General relativity became the new supreme law of the cosmos, a set of equations of breathtaking power and beauty. It could predict the bending of starlight by the sun, the subtle wobble in the orbit of Mercury, and the behavior of galaxies across billions of light years. It seemed as though we had finally grasped the ultimate architecture of reality, but hidden within the elegant mathematics of Einstein's own theory lay the seeds of its own destruction. The equations that described the universe so perfectly also predicted their own downfall. They pointed to locations where the curvature of space-time would become infinite, places where the density of matter would soar to an impossible, boundless value. These were mathematical monstrosities, points of breakdown. Einstein himself was deeply troubled by them. He believed they were a flaw in his theory, a sign that something was missing. He called them singularities. He had no idea he had just opened the first door to a lawless zone. Our first destination on this journey to the frontiers of physics is perhaps the most famous and feared object in the cosmic bestiary. It is a place of such profound gravitational power that nothing, not even light, can escape. It is the ghost of a dead star, a maelstrom in space-time. We are travelling toward a black hole. From a safe distance, a black hole is deceptively simple. It obeys the laws of Einstein's relativity with perfect fidelity. Its gravitational pull is no different from any other object of the same mass. If our Sun were to be replaced by a black hole of the same mass, Earth's orbit would remain completely unchanged. We would simply be plunged into a cold and perpetual darkness. The true strangeness begins as we approach its boundary. This boundary is not a physical surface you could touch. It is a one-way membrane in space-time, a point of no return. It is called the event horizon. Crossing it is an irreversible act, like stepping off the edge of a waterfall. Outside the event horizon, escape is still possible, if difficult. Inside, all paths, every possible trajectory in space-time lead in only one direction, inward, toward the central point of utter annihilation. The very fabric of reality is flowing inward faster than the speed of the light. To escape would require travelling faster than light itself, a fundamental violation of the cosmic speed limit. As an object falls across the event horizon, something bizarre happens. To a distant observer, the object appears to slow down, its light becoming redder and dimmer. It seems to freeze at the edge for an eternity, never quite crossing. But from the object's own perspective, it passes through the event horizon in a finite time, unaware of the temporal distortion witnessed by the outside universe. Time and space have become warped in ways that defy our everyday intuition. But even this extreme warping of reality is still described by the laws of physics. General relativity holds firm, its equations charting the path into the abyss. The true lawlessness lies deeper still, at the very heart of the black hole. As we journey toward the centre, the gravitational forces, the tidal stresses, become unimaginable. An object would be stretched and squeezed in a process grotesquely named spaghettification, pulled apart atom by atom until it is nothing more than a stream of fundamental particles. All this material, all this captured light and annihilated matter, is crushed inward toward a single, infinitesimal point. This is the singularity. And it is here that our physics, our understanding, our reality comes to a spectacular end. General relativity tells us that at the singularity, the curvature of space-time becomes infinite. The density of matter becomes infinite. The tidal forces become infinite. The word infinite in a physical theory is not a description of nature. It is a siren, a warning that the theory itself has broken down. It is the mathematical equivalent of a scream. The elegant equations of Einstein, which paint the cosmos on a grand canvas, fail completely at this single, dimensionless point. The concept of space as we know it ceases to exist. The flow of time, which has been distorted on the journey in, comes to a complete halt. Inside the singularity there is no before or after. There is no here or there. The fundamental principles of cause and effect, the bedrock of all science, may no longer apply. What happens in this lawless zone? Does the matter that falls in simply vanish from existence? Is it a gateway to another universe, with a completely different set of physical laws? Is it a point where new space-time is born? We do not know, and according to our current theories, we cannot know. The singularity is shielded from our view by the event horizon, a cosmic censor that prevents us from ever witnessing this breakdown of reality. The British physicist Roger Penrose called this the cosmic censorship hypothesis, the idea that nature abhors a naked singularity, always clothing it in the decency of an event horizon to hide its lawless nature. The black hole singularity represents a fundamental conflict at the heart of modern physics. It is the battlefield where the two great pillars of our understanding collide. General relativity, the theory of the very large, governs gravity and the structure of space-time. Quantum mechanics, the theory of the very small, governs particles, fields, and probabilities. General relativity predicts the smooth, continuous curvature of space-time, leading to the infinite singularity. Quantum mechanics, however, forbids infinities. It describes a world that is grainy, pixelated, and probabilistic at its most fundamental level. For a singularity to exist, it would mean that an immense amount of matter, perhaps many times the mass of our Sun, is compressed into a region with zero volume. Quantum mechanics, through a principle known as the Heisenberg uncertainty principle, suggests this is impossible. The more precisely you try to locate a particle, the more uncertain its momentum becomes. To confine matter to a point of zero volume would require an infinite amount of energy, creating a chaotic storm that would resist such ultimate compression. Somewhere, in the crucible at the centre of a black hole, gravity must become a quantum phenomenon. Our two greatest theories must merge into a single, unified theory of quantum gravity. We do not have such a theory yet. Until we do, the singularity remains a locked room at the heart of the cosmos, a place where the rules of reality are suspended. It is the first, and perhaps most profound, of the universe's lawless zones. But there is another, even more significant singularity in our universe's history. It is not a place you can travel to in space, but one you must travel to in time. We must rewind the cosmic clock, past the formation of galaxies, past the birth of the first stars, past the era of the first atoms. We journey back 13.8 billion years to a moment before moments. We are approaching the Big Bang. According to our understanding, the entire observable universe, every star, every galaxy, every planet, every one of us, was once compressed into a state of unimaginable density and temperature. As we trace time backward, the universe gets smaller, hotter, and denser. The equations of general relativity run in reverse lead us back to the same conclusion they reached inside a black hole. They lead to an initial singularity, a point of zero size and infinite density that contained everything. This was not an explosion in space. It was an explosion of space. There was no outside for the Big Bang to expand into. Space and time themselves were born in this primordial event. To ask what came before the Big Bang is, from the perspective of general relativity, a meaningless question. It is like asking what is north of the North Pole. Time itself begins at this singularity. This is the ultimate lawless zone. If the black hole singularity is a place where the laws of physics break down, the Big Bang singularity is the moment before the laws of physics even existed. The four fundamental forces of nature that govern our universe today, gravity, electromagnetism, and the strong and weak nuclear forces, were, in that initial inferno, thought to be merged into a single, unified superforce. The very distinctions that define our physical reality had not yet crystallized. This era, lasting for an infinitesimally small fraction of the first second, is known as the Planck epoch. It lasted from time 0 to approximately 10 to the power of minus 43 seconds. During this fleeting primordial instant, the universe was smaller than a subatomic particle. The temperature was a staggering 10 to the power of 32 degrees. The concepts of size, temperature, and even time become fluid and ill-defined. Here, in this quantum furnace, the conflict between general relativity and quantum mechanics is at its most extreme. The universe was simultaneously incredibly massive and incredibly tiny. It was the exclusive domain of quantum gravity. What was this state? It was not matter as we know it. It was a roiling, chaotic foam of pure potential, a cauldron of nascent reality. The laws that would later dictate the precise charge of an electron, the strength of the gravitational constant, the speed of light. None of these were yet set in stone. They emerged as the universe expanded and cooled, like crystals forming in a supersaturated solution. Why did they take on the specific values they did? Could they have been different? This Genesis moment, this primordial lawless zone, is the greatest mystery in all of science. It is the ultimate source of everything, yet it is a state that our current physics cannot describe. It is the blank page upon which the story of our cosmos was written, and the author and the language remain unknown to us. Our best theories, like inflation theory, attempt to describe the moments just after this epoch, a period of hyper-accelerated expansion that smoothed out the universe and seeded the structures we see today. But inflation theory begins after the initial singularity. It does not explain the origin point itself. It pushes the problem of the lawless zone back to an even earlier, more inaccessible point in time. The Big Bang singularity forces upon us a profound and humbling realization. Our entire universe, with its elegant order and intricate structures, may have emerged from a state of pure lawless chaos. the cosmic rulebook that we have worked so hard to decipher, may be just one possible outcome of an event for which there were no rules at all. We have visited the lawless zones of the infinitely large and the infinitely dense. But there is another domain where the rules of reality become strange and fluid. We do not need to travel to the edge of time or into the heart of a black hole to find it. This realm of chaos is all around us. It is within us. It exists at the very bottom level of reality, at a scale so small it defies imagination. We must now zoom in, far past the scale of molecules and atoms, past even the protons and neutrons of the atomic nucleus. We are entering the realm of the Planck length. This is a distance of 1.6 times 10 to the power of minus 35 meters. To grasp this scale, imagine an atom. Now expand that single atom to the size of the entire observable universe. The Planck length would, on that scale, be about the height of a single tree. It is the fundamental pixel of reality, the smallest possible meaningful distance. At this submicroscopic level, the smooth geometric fabric of Einstein's spacetime is thought to break down. The celebrated physicist John Wheeler gave this realm a haunting name, the quantum foam. Think again of the surface of the ocean. From an airplane high above, the ocean appears perfectly smooth and flat. This is the universe as seen by general relativity, a gentle curving geometry. But as you descend closer, you see that the surface is not smooth at all. It is a chaotic mess of waves, ripples and bubbles, constantly in motion. This is the view of space-time at the Planck scale. It is not a tranquil fabric. It is a violent, roiling sea of quantum energy. Here, the Heisenberg uncertainty principle reigns supreme. This principle states a fundamental limit to the precision with which we can know certain pairs of properties, such as a particle's position and its momentum. A similar uncertainty exists for energy and time. Over extremely short time intervals, the universe is allowed to borrow energy from the vacuum. This borrowed energy can spontaneously erupt into pairs of virtual particles and antiparticles, which exist for a fleeting moment before annihilating each other and repaying the energy debt. The vacuum of space, which we think of as empty, is in fact a cauldron of this activity. The quantum foam is this principle taken to its ultimate extreme. Space-time itself is subject to quantum uncertainty. At the Planck scale, the fabric of reality is constantly tearing and repairing itself. Tiny, ephemeral wormholes and microscopic, short-lived black holes may be popping in and out of existence in a continuous, chaotic frenzy. In this domain, causality becomes foggy. The neat chain of cause and effect that governs our macroscopic world dissolves into a cloud of probabilities. An event at one point in space-time can influence another without any clear path between them. Time itself may lose its smooth forward direction, becoming a fractured, branching set of possibilities. This underlying layer of lawlessness is usually hidden from us. Its effects are so small and happen so quickly that they average out on larger scales, giving us the smooth, predictable reality we experience. The chaotic foam is smoothed over, just as the turbulent ocean appears flat from a great height. But this fundamental chaos might be the source of everything. Some cosmologists believe that the tiny quantum fluctuations in this foam, during the initial inflationary burst of the Big Bang, were stretched to astronomical proportions. These stretch fluctuations became the seeds of cosmic structure. The slight variations in density in the early universe, the very imperfections that allowed matter to clump together to form galaxies, stars, and ultimately us, may have their origins in the lawless chaos of the quantum foam. So, our ordered universe, with its reliable laws, may be built upon a foundation of pure anarchy. We are living on a calm, macroscopic island, blissfully unaware of the tempestuous quantum ocean that rages just beneath the surface of reality. This is a lawless zone, not in some distant place or time, but interwoven with the very fabric of our existence, the hidden, chaotic engine that drives the cosmos. We have stared into the abyss of the singularity, journeyed back to the genesis moment of time, and peered into the subatomic froth that underpins reality. These are the frontiers where our known physics fails, but science does not stand still. The existence of these lawless zones is not an admission of ultimate defeat, but rather the greatest challenge and motivator for a new generation of physicists. The quest is on for a theory that can conquer these domains of chaos, a theory that can unite the warring kingdoms of general relativity and quantum mechanics. This hypothetical framework is often called a theory of everything, though a more accurate name might be a theory of quantum gravity. Leading candidates such as string theory and loop quantum gravity attempt to provide a picture of what happens when gravity becomes a quantum force. String theory, for example, replaces the idea of point-like particles with unimaginably small, vibrating one-dimensional strings. The different vibrations of these strings give rise to all the different particles and forces we observe. In this view, the Big Bang singularity is not a point of infinite density, but perhaps a collision between two higher-dimensional branes, or a transitional bounce from a previous contracting universe. The singularity is resolved, replaced by a new, though no less strange, set of physics. Loop quantum gravity takes a different approach. It quantizes space-time itself, suggesting that the fabric of reality is made of discrete, indivisible loops. Space is not continuous but granular. There is a smallest possible volume, a fundamental atom of space. In this model, you can never crush matter down to a point of zero volume. As matter collapses in a black hole or at the beginning of time, it reaches a maximum possible density and then bounces back. The singularity is again avoided, replaced by a Planck star or a big bounce. These theories are still highly speculative and currently beyond our ability to test experimentally. They exist in the realm of pure mathematics, beautiful and compelling ideas searching for a connection to the physical world, but they represent our best hope for finally understanding the lawless zones. They promise to write the missing chapters in the cosmic rulebook, to provide the grammar for the language spoken at the heart of a black hole and at the beginning of time. Yet, even as we search for a more fundamental set of laws, we are forced to confront a profound philosophical question. What if our assumption of a single universal rulebook is wrong? The existence of singularities suggests that the universe contains states of being that are fundamentally inaccessible to our current mode of scientific inquiry. What if these are not just failures of our theories, but true exceptions to cosmic order? Could it be that the universe is not a single, unified legal system, but more like a patchwork of different jurisdictions? Perhaps within a black hole, a new universe is born with its own slightly different physical laws. Physicist Lee Smolin's theory of cosmological natural selection proposes just this. Universes are born from the singularities of black holes, and those universes whose physical constants are more likely to produce black holes will have more offspring, eventually dominating the multiverse. In this vision, the lawless zone is a crucible of cosmic creation, a place where the rules of reality themselves are forged and tested. This leads us to an even grander, more unsettling thought. Our universe appears incredibly fine-tuned for the existence of complexity and life. Change the strength of gravity, the charge of an electron, or the expansion rate of the universe by even a tiny fraction, and the cosmos would have been a sterile, empty void. Why is our universe so special? Perhaps it isn't. Perhaps our ordered, life-sustaining cosmos is just one island of stability, one lucky draw in an infinite multiverse of possibilities. Most of these other universes might be chaotic, stillborn realities, with laws that do not permit the formation of stars or atoms. In this grander perspective, our entire universe, governed by its elegant laws, is itself an exception, a fluke of cosmic chance. The truly fundamental state of existence might not be order, but chaos. Our laws of physics might not be universal statutes, but merely the local bylaws of our particular cosmic neighborhood. Our journey has taken us to the absolute limits of knowledge. We have found that the foundation of our reality, the very laws we hold to be immutable, are built upon and surrounded by zones of profound mystery. From the infinite compression inside a black hole, to the unknowable genesis of the Big Bang, to the restless quantum foam that permeates all of space, we are confronted by the breakdown of our most cherished certainties. These lawless zones are not just puzzles for physicists to solve. They are windows into the true nature of existence. They teach us humility, showing us the vastness of our own ignorance. They inspire awe, revealing a universe far stranger and more complex than we ever imagined. and they give us purpose. For the greatest adventure of the human intellect is to stand at the edge of the abyss of the unknown and to not be afraid. It is to look into the heart of chaos, where all rules are broken, and to dare to ask the question, why? The final answers may lie forever beyond our grasp, hidden behind event horizons or shrouded in the fog of the first moment of time. But the quest to understand these ultimate frontiers, to chart the lawless territories of the cosmos, is the noblest and most profound journey we can ever hope to undertake. It is the journey to understand not just the universe, but our own place within its magnificent and perhaps lawless design. "700 million light-years from Earth, the architecture of reality fails. We found a region where existence simply stops. Deep within the constellation of the herdsman, there is a spherical dead zone 330 million light-years wide. Physical matter is strictly forbidden here. It is an amputated limb of the night sky. Light travels across millions of years, only to die in the dark. If you enjoy what we create here, like and subscribe. Take a breath. We go in." To comprehend the scale of the Bhuta's void is to confront an impossible absence. When astronomers first pointed their most powerful telescopes toward this patch of the celestial sphere, they expected the familiar hum of the cosmos. They anticipated the vibrant light of countless stellar nurseries, the swirling disks of ancient galaxies, and the dense dust lanes that form the backbone of our universe. Instead, their instruments returned profound silence. This space is a desert of pure nothingness. The universe does not just lack matter here, it actively rejects it. Across a distance so vast that a beam of light requires hundreds of millions of years to cross it, the fundamental building blocks of reality have been entirely stripped away. We measure the light from distant quasars passing through this region, and the spectral lines show almost no trace of hydrogen gas. There is no dust. There is no foundation for creation. For decades, humanity believed the cosmos was an even fabric. We trusted that galaxies were distributed like cities on a map, woven together by gravity in a predictable web. Our meticulous surveys of the night sky revealed that the universe is structured like a vast sponge. There are immense glowing filaments of dark matter and gas, and along these invisible rivers, galaxies flow and cluster together into brilliant metropolises. Between these shining threads lie the voids. We always knew voids existed. They are a natural consequence of gravity pulling matter together, but they were expected to be small, manageable gaps in the grand design. Then, the deep space mapping surveys returned the data for the Bhuta's void. Inside this colossal vacuum, a handful of prisoners drift. There are only about 60 galaxies trapped within a space that should easily contain 10,000. They are stragglers wandering a barren wasteland, forced to cannibalize their own bodies to survive. Scientists patiently observe the faint, fading light from these isolated star systems. They do not look at this data with terror, but with the quiet, electric thrill of discovering nature at its absolute limit. They carefully calibrate their lenses, analysing the wavelengths of starlight to understand how a galaxy survives in total isolation. The physical evidence is stark. The void starves them. The surrounding vacuum is greedy, pulling away whatever loose gas and dust these galaxies might possess. In a healthy galactic environment, fresh hydrogen constantly falls inward, fueling the birth of bright blue stars. But here, the supply lines are permanently severed. Left without raw materials, these galaxies are deformed. They cannot form new stellar generations. They rely on old, red, dying stars to maintain their structure. The galaxies here do not shine. They choke. The mystery deepens when we turn our gaze away from the visible light and look back to the very dawn of time. We observe the cosmic microwave background. This is the afterglow of the Great Expansion, the earliest light of creation emitted over 13 billion years ago. The temperature of this ancient radiation is incredibly uniform, providing a steady, reliable baseline for the entire physical world. The cosmos should display an even distribution of heat, with only microscopic, predictable ripples. It is not uniform here. When researchers map the thermal blueprint of the sky, a sudden, deep cold spot aligns perfectly with the boundaries of the void. The cosmos is bleeding heat into nowhere. It is a puncture wound in the skin of our reality. As ancient photons travel from the edge of the universe toward our detectors on Earth, they must cross this immense emptiness. As they enter the void, they lose energy climbing into the dark. Because the universe is constantly expanding, the void stretches and grows, while the light is still trapped inside. By the time the photons finally escape the far side, they cannot regain the energy they sacrificed. They arrive at our telescopes exhausted, stretched into long, cold wavelengths. We map the temperature. We measure the expanse. The astronomers lean closer to their screens, running the simulations one more time, feeling the profound weight of a shifting paradigm. The numbers do not work. The physical dimensions of the Butter's void present a severe chronological paradox. Voids in the cosmic web grow through a slow, methodical process of merging. Small pockets of empty space collide and combine, expanding over eons like soap bubbles in a vast foam. This architectural process is governed by the steady, unyielding pull of gravity drawing matter outward into the dense filaments. But time betrays the math. The universe is exactly 13.8 billion years old. Our most robust cosmological models dictate the precise rate at which structural formations can occur. To clear a space 330 million light-years wide requires a sequence of gravitational mergers that demands far more time than the universe has existed. It is mathematically equivalent to finding a fully grown oak tree inside a house that was built yesterday. Imagine standing in the exact centre of the Pacific Ocean. You drop a single grain of sand into the water and you expect it to collide with another specific grain drifting thousands of miles away. That is the density of this space. To empty an ocean of that size, to push every single particle of matter to the distant shores, requires an eternity. The void is older than the rules that govern it. Faced with this impossible scale, our scientists do not surrender. They embrace the friction between the data and the theory. They recognize that our understanding of gravity, of cosmic expansion, and of time itself must be fundamentally incomplete. When the rigid mechanics of orbital paths and gravitational wells fail to provide an answer, a new, majestic perspective emerges. We must shift our view and treat the universe not simply as a cold machine, but as a living, breathing entity. The structure of the cosmos behaves remarkably like biological tissue, with energy flowing through vital pathways. Under this lens, the immense emptiness of Bhutas requires a different interpretation. It is not a structural flaw, it is a symptom. If we view the cosmic web as a living architecture, the void represents a terminal decay. It is a necrosis. It is a black spot on a medical scan of the night sky. The hollow heart of the universe is failing, and it consumes the healthy tissue around it. We're not looking at empty space. We're watching an infection spread. Because the void is completely empty, it acts as a massive gravitational repeller. The ultra-dense walls of galaxies surrounding the void pull matter away from the centre with relentless force. The emptiness feeds itself by pushing everything else away. It is an awe-inspiring mechanism of subtraction. It demonstrates how delicate the balance of forces must be to allow a galaxy, a star, or a planet to exist at all. Looking deeply into the Bhutas void forces the human mind to cross a difficult threshold. It demands that we confront the exact mechanism of our own future erasure. When you stand outside and look up at the night sky, you inherently trust the light. You find comfort in the steady presence of the stars. You believe that illumination is the natural order of things, But observing the great void reminds your brain that the dark is the default state of reality. Light is merely a temporary condition. This realization induces a profound intellectual vertigo. It bridges the grand, untouchable scale of the cosmos with the quiet internal landscape of human awareness. We are not frail creatures. We are brilliant observers, uniquely capable of comprehending the scale of our own insignificance. Right now, through the glass of our telescopes, we are looking directly into the abyss, and it is showing us exactly how we will be forgotten. There will be no dramatic collapse. There will be no violent shattering of the heavens. It will just be a slow, quiet fading of the lights. The abyss does not stare back. It simply waits. The trajectory of this slow fade is already written in the fundamental forces of nature. The great engine driving this process is dark energy. This mysterious unseen pressure is actively accelerating the expansion of the fabric of space. It pushes the galaxies apart, stretching the cosmic web until the threads begin to snap. In this grand cosmological picture, the Bhuta's void is not just a localized anomaly, it is the final blueprint. As the eons pass, the walls of the void will inevitably expand. Driven by the relentless pressure of dark energy, the empty space will push against the neighbouring filaments of the cosmic web. It will swallow the surrounding star clusters. The gravity that holds galaxy groups together will ultimately lose the war against the expansion of space itself. Tomorrow is not a destination. It is solitary confinement. Eventually, the outward rush of dark energy will accelerate to a point where light from one galaxy can no longer reach another. The vast oceans of empty space will isolate every surviving structure. Every galaxy will become a prisoner in its own kingdom of nothing. For any civilization looking up at the sky in that distant era, the universe will appear entirely empty. The stars within their own galaxy will slowly burn through their nuclear fuel, transforming into cold white dwarfs, silent neutron stars, and lightless black holes. The ambient temperature of the expanding voids will drop toward absolute zero. The primordial heat of creation, the glorious energy that sparked the birth of billions of galaxies, will disperse into an endless, unyielding frost. The living web of the cosmos will dissolve into a state of total, permanent isolation, where no signal, no matter how powerful, can ever cross the dark. The void will be everything. To understand the magnitude of this cosmic absence, we must look backward to the moment humanity first realized the map was torn. The grand tapestry of the universe was not unraveled by a sudden, terrifying revelation. It was unraveled slowly through the quiet, meticulous labour of men and women sitting in freezing observatories, staring at numbers on a screen. It is the early 1980s. High atop a mountain peak, shielded from the dense light pollution of earthly cities, the air is thin and bitterly cold. A small team of astronomers, led by Robert Kirshner, occupies the control room of a massive telescope. The mechanical gears of the observatory dome grind softly in the dark, adjusting the colossal mirror to capture the faint echoes of the deep sky. These scientists are not searching for anomalies. They are cartographers of the infinite. They have taken upon themselves a monumentally tedious task. They are mapping the three-dimensional positions of galaxies in the northern hemisphere, aiming to build a precise, mathematical model of our cosmic neighbourhood. The work is agonizingly slow. To determine the distance of a galaxy, these researchers do not simply take a photograph. A two-dimensional image cannot reveal depth. Instead, they must capture a single beam of light, a fragile stream of photons that has survived a journey of hundreds of millions of years through the vacuum. They take this ancient light and pass it through a spectrograph, a specialized instrument that slices the beam and stretches it into a barcode of raw colors. This process relies on the fundamental physics of an expanding universe. As the fabric of space stretches, the light travelling through it is also stretched. The light waves are pulled apart, becoming longer. In the visible spectrum of human optics, longer wavelengths appear red. Therefore, the further away a galaxy resides, the more its light shifts toward the red end of the spectrum. By measuring the exact degree of this redshift, the astronomers can calculate the precise distance the light had to travel. They lock onto a galaxy, they measure the redshift, they log the coordinates, they record the distance, they plot the point on their three-dimensional map. They repeat this process thousands upon thousands of times. It is a profound monument to human persistence. They turn their instruments toward the constellation of the herdsman. They plot a glowing cluster of stars at 300 million light-years away. They plot another at 400 million. But as they push their instruments deeper, reaching into the 500 million light-year range, the data suddenly fails. The photographic plates show nothing. The spectrographs return flat, empty lines. The colourful barcode of the universe goes completely blank. A lesser mind might assume a failure of the machine. The scientists do not panic. They do not succumb to a sudden wave of cosmic dread. They lean forward into the monitors. Their immediate assumption is an error in their own methodology, because science is built entirely upon a foundation of cautious skepticism. They hypothesize that a massive invisible cloud of interstellar dust might be obscuring their line of sight. They suspect the calibration of the telescope mirror is drifting out of alignment. They spend weeks checking and rechecking the instruments. They recalibrate the spectrographs. They point the massive lenses of the observatory back at the exact same patch of dark sky, leaving the camera shutters open for hours at a time, commanding the machine to gather every possible scrap of stray light. They run the mathematical models again and again. The data remains stubbornly, beautifully empty. The quiet excitement in the control room begins to build into a profound realization. They verify every cable, every lens, every line of code. Their equipment is flawless. The anomaly is real. They have not found a blind spot in the telescope. They have found a hole in reality itself. When the team finally publishes their findings in 1981, they present a paper detailing an impossibly massive void. The scientific community responds not with fear, but with a collective gasp of intellectual awe. At the time, the reigning astrophysical models predicted only minor fluctuations in the distribution of matter. A gap of this magnitude shatters the existing framework entirely. It forces the finest minds on the planet to return to their blackboards. This is the exact friction that drives human knowledge forward. The astronomers have handed humanity a puzzle of incomprehensible proportions, and the scientific world eagerly accepts the challenge. Years pass. Telescope technology advances at an exponential rate. The instruments grow vastly more sensitive, capable of detecting the faintest whispers of stellar radiation from the deepest corners of the abyss. A new generation of astronomers returns to the Bhutas region. They are determined to see if the emptiness is truly absolute, or if the initial surveys simply lacked the necessary power. They launch highly targeted observation campaigns. They slice the void into microscopic layers of visual data. Deep within the wasteland, they find the stragglers. They locate the handful of isolated, deformed galaxies drifting in the dark. But finding these few stellar systems does not diminish the profound nature of the emptiness. It amplifies it. Imagine surveying a desert the size of an entire continent and finding only 3 individual grains of sand. The presence of these solitary wanderers provides researchers with a crucial piece of physical evidence. By studying the specific wavelengths of light emitted by these surviving galaxies, scientists can measure the precise chemical makeup of the surrounding void. They search for the faint emission lines of hydrogen and helium gas. They discover that the space between these isolated galaxies is cleaner than the most perfect vacuum chamber ever constructed in an earthly laboratory. An astronomer named Greg Aldring, who spent years peering into this specific abyss, perfectly encapsulated the scale of the discovery. He noted that if the Milky Way galaxy had been placed in the exact center of the Bhutas void, Human beings would not have known that other galaxies existed until the invention of deep space telescopes in the 1960s. Let that vastness settle into your mind. If our solar system had formed inside that dead zone, human history would have unfolded under a profoundly different night sky. We would have believed our single spiral of stars was the entirety of creation. The night sky beyond the edges of our immediate galactic neighbourhood would have been a flawless, unbroken curtain of absolute black. We would have felt completely, existentially alone. Instead, our planet is positioned in a rich, crowded suburb of the cosmic web. This precise placement allows us to look out across the intervening millions of light years and perceive the void from a safe distance. We are granted the privilege of observation. The precision required to measure the true emptiness of this region is staggering. To confirm the absence of matter, astronomers utilize a brilliant technique involving quasars. These are the intensely bright, supermassive black holes at the cores of distant ancient galaxies. They find quasars situated far behind the Bylaws region. The scientists use these brilliant beacons exactly like cosmic lighthouses. As the intensely bright beam of light from the quasar pierces through the void on its journey toward Earth, any trace amounts of cold gas hidden in the darkness will absorb specific wavelengths of that light. When the beam finally reaches our orbital detectors, researchers look at the spectrum and search for the missing colours. The absorption lines tell the story of whatever the light touched on its long journey. It is a forensic analysis of a photon. When the light travelling through Bylaws arrives at our sensors, it is nearly untouched. There are no missing colours. There are no hidden clouds of gas. The void leaves absolutely no fingerprints on the light. This rigorous, methodical process is a profound testament to the capability of the human intellect. We are small, fragile entities bound by gravity to a single rock, orbiting an entirely ordinary star. Yet, we have built crystalline eyes that can gather the ancient echoes of creation. We have developed complex mathematics that can decipher the invisible architecture of nothingness. We do not just look at the darkness, we weigh it, we measure its borders, we map its historical trajectory. The scientists parsing this data are acting as the sensory organs of the universe itself. Through our curiosity, the cosmos is finally able to comprehend its own vastness. The confirmation of the Bylaws void permanently alters the trajectory of astrophysics. It proves beyond a shadow of a doubt that the great expansion of reality is not a smooth, perfectly orchestrated outward breath. It is a violent, chaotic process. The existence of a structure this large immediately forces a re-evaluation of everything we understand about the invisible forces governing the universe. If dark matter provides the invisible gravitational scaffolding upon which the cosmic web is built, then the void represents a monumental failure of that scaffolding. According to every known law of physics, the gravity of dark matter should have slowly pulled ambient gas and cosmic dust into this region over billions of years. Instead, the dark matter itself is entirely missing. The foundation of reality has been carved out. The researchers sit in their brightly lit offices, surrounded by topographical maps of the sky. They trace the curved edges of the Bylaws anomaly with their fingers. A new consensus begins to form. They realise that to truly understand the mechanics of the void, they must stop looking directly into the empty centre. They must shift their focus to the borders, the massive ultra-dense walls of clustered galaxies that enclose the emptiness hold the next crucial clue. The sheer gravitational mass of the perimeter is actively shaping the vacuum within. The investigation expands. The silent observers of Earth prepare to look even deeper, pushing their intricate instruments to the absolute breaking point of physical measurement. The void itself is a silent, unmoving monument, but its edges are screaming with cosmic energy. The borders of the great emptiness are screaming with cosmic energy. To understand why the edges of this abyss are so violently active, we must abandon the idea that empty space is merely a passive background. The scientist analysing the structural perimeter of the Bylaws region have discovered a terrifying and majestic truth. The void is not a quiet, empty room. It is a highly active thermodynamic engine of pure physical subtraction. To decipher the mechanical reality of this space, humanity deployed one of the most sensitive instruments ever constructed. We launched the Planck satellite into the silent frozen stability of Lagrange Point 2. Positioned 1 million miles from Earth, with its back turned forever toward the glaring heat of the sun, the satellite was cooled to just 1/10 of a degree above absolute zero. It was designed to measure the microscopic temperature variations of the ancient cosmic microwave background. It did not look at galaxies, it looked at the invisible foundation of space itself. The data returned by the Planck mission and its predecessor, the Wilkinson Microwave Anisotropy Probe, required immense computing power to process. When the theoretical physicists and cosmologists finally rendered the raw data into a visual map, they did not just confirm the presence of the void, they uncovered the exact physical mechanism of how it drains energy from the universe. This mechanism is known in the rigid architecture of astrophysics as the integrated Sachs-Wolf effect. It is a profound demonstration of how gravity and light interact over unfathomable spans of time. To understand this effect, we must track the journey of a single ancient photon of light. This photon is born in the glowing plasma of the early universe, travelling for billions of years across the expanding cosmos. Eventually, its trajectory brings it to the edge of the Brutus void. In the laws of general relativity, an area heavily packed with dark matter and galaxies creates a deep gravitational well. Conversely, a massive void creates a gravitational potential hill. When our ancient photon reaches the dense wall of galaxies bordering the void, it must climb this invisible hill to enter the emptiness. In physics, climbing requires work. As the photon climbs the gravitational incline, it expends energy. In the language of light, a loss of energy means its wavelength stretches, becoming cooler and redder. If the universe were static, the photon would travel across the vast empty expanse, reach the other side, and fall back down the gravitational hill. As it fell, it would perfectly regain all the energy it lost during the climb. The energetic ledger would be perfectly balanced. But the universe is not static. It is constantly expanding, driven by the relentless negative pressure of dark energy. While the photon makes its agonizingly slow journey across the 330 million light-year expanse, the dark energy within the void is actively pushing the boundaries outward. By the time the photon finally reaches the opposite edge millions of years later, the entire structure is stretched. The gravitational hill has flattened out. Therefore, when the photon falls down the far side, the drop is much shorter than the climb it originally made. It cannot regain the energy it spent. It exits the void permanently altered, fundamentally drained of its heat. This is why the telescopes on Earth detect a massive cold spot aligning with the emptiness. The void is actively robbing the oldest light in the universe of its thermal energy. It is a spectacular theft, written in the rigorous mathematics of quantum mechanics and relativity. The researchers sitting at their terminals, reviewing the output of the Planck satellite, marvel at the elegance of this thermodynamic trap. They observe the data with deep reverence, watching a fundamental law of physics operate on a scale so vast it humbles the human mind. Yet the thermal signature only explains how the void interacts with passing light. It does not explain how the emptiness generates the physical force necessary to crush the galaxies at its borders. To solve this, astronomers turn to the Baryon Oscillation Spectroscopic Survey. This massive collaborative project utilizes the Apache Point Observatory to map the acoustic sound waves frozen in the distribution of galaxies. In the dense, chaotic plasma of the infant cosmos, immense sound waves rippled through matter like ripples in a pond. When the universe cooled, these waves were locked into place, establishing the foundational grid upon which all galaxies would eventually form. By analysing the spacing of these frozen acoustic waves, Astrophysicists can measure the exact interplay between gravity and dark energy. Within the dense filaments of the cosmic web, gravity is the absolute monarch. The immense concentration of dark matter pulls ordinary matter together, forging stars and galaxies, resisting the outward expansion of the universe. Gravity holds the glowing cities of the cosmos intact, but inside the Bhuta's region, the density of matter drops to virtually zero. Without the anchoring presence of mass, gravity loses all its power. In this total vacuum, dark energy becomes the undisputed ruler. Dark energy is an intrinsic property of space itself. It exerts a constant, repulsive negative pressure. Because there is no gravity inside the void to contest this outward push, the empty space acts like an immense, overpressurized piston. The emptiness physically pushes outward against the surrounding cosmic web. This is why the borders of the void are incredibly dense. The emptiness is operating as a colossal snowplow. Over billions of years, the unyielding outward pressure of the void has swept all the ambient gas, dust and dark matter out of the centre, crushing it into the massive glowing walls that define its perimeter. These 60 malformed galaxies trapped inside are simply the heaviest remnants, the stellar anchors that possess just enough mass to resist the outward tide of the vacuum. The mechanics are flawless. The emptiness is entirely weaponized by dark energy. But a profound question remains. How does a void gather enough momentum to become this large? The laws of physics dictate that cosmic voids grow by merging together over time, but the Bhuta's region is so exponentially massive that even the long age of the universe cannot fully account for its current dimensions. To find the seed of this colossal absence, theoretical physicists must look away from the macroscopic scale of deep space. They must look backward to the microscopic subatomic realm of quantum mechanics. They trace the origin of the void to a theory known as cosmic inflation. In the very first fraction of a single second after the creation of the universe, reality existed as a turbulent microscopic sea of quantum foam. In this chaotic quantum state, energy constantly fluctuated. There were microscopic peaks of high density and microscopic valleys of low density. These variations were infinitely smaller than a single proton. Then, cosmic inflation occurred. The fabric of reality expanded at a speed vastly exceeding the speed of light. In less than a blink of an eye, the microscopic universe ballooned to macroscopic proportions. The quantum fluctuations were instantly frozen and magnified to a cosmic scale. A microscopic peak of energy became the dense gravitational seed that would eventually grow into a massive supercluster of galaxies. And a microscopic valley, a tiny, infinitesimal dip in the quantum field, was stretched into a massive region of underdensity. The Bhuta's void is not an accident of galactic movement. It is a primordial scar. It is a direct, magnified imprint of a quantum anomaly that occurred at the exact moment of creation. The immense emptiness we observe today is simply the consequence of that initial quantum deficit, given 13.8 billion years to expand and push the surrounding matter away. This realization bridges the absolute extremes of human knowledge. The cosmologists map the largest known structure in the natural world, only to discover that it is governed entirely by the mathematics of the smallest known particles. The massive telescope mirrors and the microscopic particle accelerators are telling the exact same story. The scientists do not shrink from this vastness. They lean into the monitors, entirely captivated by the symmetry of nature. They write complex algorithms to simulate the exact expansion rate of the primordial quantum seed. They input the variables of dark energy, the density parameters of dark matter, and the thermodynamic equations of the Sachs-Wolf effect. They watch the digital simulation of the universe unfold on their screens. They see the tiny quantum valleys expand, merging and pushing against the bright threads of the cosmic web. They watch the engine of nothingness carve out its territory. Our capability to reconstruct this monumental sequence of events is a quiet triumph of the human intellect. Through mathematics and observation, we have taken an invisible force operating in total darkness, and we have brought it into the light of absolute understanding. We have stripped away the mystery, leaving only the hard, unyielding mechanics of reality. We now know precisely how the void breathes. We know exactly why it is cold. We know the mechanical origin of its immense power. But unravelling the physical mechanisms of the void inevitably brings us to a far more profound realization. The engine is perfectly understood, but the engine is still running. The meticulous scientific models prove that the repulsive force of dark energy is not a temporary phase, it is an accelerating constant. By understanding exactly how the Beauty's anomaly functions today, the scientific community is forced to look ahead at what this mechanism will eventually do to the rest of the cosmic web. The void is no longer just an object of rigorous study. It becomes a temporal mirror. The physics are entirely resolved, but the implications of those physics cast a long, chilling shadow over the future of the cosmos. The machine of reality is functioning exactly as the equations predict, and it is methodically preparing for the end. The realization that this immense mechanism of nothingness is actively accelerating brings us to a profound paradox of observation. We are observing the Beauty's anomaly through a window of time that is steadily and permanently closing. The very light that allows us to map the void is fighting a war against the expansion of space, and it is a war that light is destined to lose. To fully dissect the consequences of this expanding dead zone, we must examine the ultimate limit of physics. The speed of light is the absolute speed limit for the transfer of information in the cosmos. Nothing can move through space faster than this fundamental constant. However, there is a crucial caveat in the laws of general relativity. While nothing can move through space faster than light, space itself is not bound by this restriction. Space can expand at any speed. As the unyielding pressure of dark energy continues to stretch the geometry of the void, the physical distance between the dense walls of galaxies grows. At immense cosmic scales, this expansion is cumulative. The more space there is between 2 points, the more space there is to expand. Because the Beauty's void is so incomprehensibly massive, the rate at which its opposite shores are moving apart is staggering. Eventually, the expansion of the void will accelerate to a point where the distance between two opposing galaxies increases faster than the speed of light. When this threshold is crossed, a cosmological event horizon is established. Once a galaxy slips beyond this invisible boundary, no photon it emits will ever be able to cross the expanding gulf of the void to reach the other side. The light will be travelling forward at its maximum possible velocity, but the fabric of space beneath it will be stretching backward even faster. It is exactly like a runner sprinting on a treadmill that is moving faster than their top speed. The light will never arrive. The visual connection will be permanently severed. This is the severe scientific consequence of the expanding emptiness. The void is not merely pushing matter away. It is systematically deleting information from the observable universe. The astronomers and astrophysicists who calculate these expansion rates do not view this data with despair. They possess a profound, quiet resilience. They sit at their desks reviewing the complex tensor equations that describe the metric expansion of space, and they feel a deep sense of privilege. They recognize that humanity exists in a golden era of cosmology. We live in a precise cosmological window where the universe is old enough to have formed massive structures, yet young enough that light can still cross the great abysses to tell us the story of their formation. The scientists understand that they are working against a cosmic clock. They point their telescopes into the dark with meticulous urgency, knowing that they must capture the light of these distant structures now, before the expansion of reality stretches them into an undetectable, infinite flatline. The universe is erasing its own history. This paradox of observation extends inward into the very heart of the void itself. Let us narrow our focus and look again at the 60 isolated galaxies trapped within the emptiness. In the early days of astronomical surveys, these solitary systems were viewed as tragic anomalies. They were seen as cosmic outcasts, starved of the vital gases necessary to sustain a vibrant galactic life. But as our observational tools grew more sophisticated, a new and startling perspective emerged from the data. To understand the fate of these prisoners, we must examine the violent mechanics of a normal galactic environment. In the dense, glowing filaments of the cosmic web, galaxies are constantly interacting. They are pulled together by the immense gravity of dark matter. They collide, tearing massive streams of stars from each other. They plunge through vast, turbulent clouds of intergalactic gas. These violent encounters create immense friction, compressing clouds of hydrogen and triggering explosive waves of star formation. The galaxies in the crowded regions of the universe live bright, chaotic and volatile lives. Inside the Bhuta's void, it is perfectly calm. Because the void is stripped of ambient gas and dark matter, the galaxies within it do not collide. They do not experience the violent gravitational disruptions common in the wider universe. They exist in a state of pristine, undisturbed isolation. This absolute isolation completely alters their internal evolution. Without the continuous inflow of fresh, primordial gas from the cosmic web, these trapped galaxies cannot ignite large, massive stars. In the universe, the largest stars are brilliant blue and incredibly hot. They burn through their nuclear fuel in a few million years and detonate in catastrophic supernovae. In the void, these massive stars died out billions of years ago, and the galaxies lack the raw materials to replace them. The magnificent glowing spiral arms that characterize young galaxies slowly fade away. What remains is a population of incredibly efficient survivors. The isolated galaxies transform into quiet communities of red dwarfs. Red dwarfs are the smallest, coolest, and dimmest stars in the natural world. Because they have so little mass, their internal gravitational pressure is low. They process their hydrogen fuel at an incredibly slow, methodical rate. While a massive blue star might burn out in 10 million years, a red dwarf can continue to shine for trillions of years. They are the ultimate engines of longevity. Here we find the magnificent paradox of the stragglers. The emptiness of the void denies these galaxies the materials needed for a bright, explosive youth. But by shielding them from the violent collisions and the chaotic environments of the cosmic web, the void grants them an impossibly long life. They are safe from the massive galactic mergers that frequently tear stellar systems apart. They burn their remaining fuel with absolute perfect efficiency. Long after the great shining metropolises of the cosmic web have collapsed into cold debris and black holes, the tiny red stars of the Bhuta's void will still be burning. Isolation breeds extreme longevity. This rigorous analysis of stellar evolution forces us to reconsider the nature of the void entirely. We intuitively look at the dark spaces on the map and assume they represent death. We look at the shining clusters of matter and assume they represent life. But the data reveals a far more complex reality. The dense, shining structures of the universe are highly unstable. They are burning themselves out at a staggering pace. The void, by contrast, represents perfect thermodynamic stability. This brings us to a radical shift in our existential understanding of the cosmos. When scientists simulate the long-term future of the universe, they must confront the laws of thermodynamics. The second law dictates that the total entropy of an isolated system can never decrease. Entropy is often described as disorder, but in the realm of astrophysics it is more accurately described as equilibrium. It is the dispersal of energy until everything is perfectly uniform. The cosmic web, with its tight clusters of matter, its burning stars, and its massive gravitational wells, is a state of extremely low entropy. It is a highly organized, highly concentrated arrangement of energy. From a thermodynamic perspective, the cosmic web is an unnatural state. It is a temporary rebellion against the fundamental laws of nature. The Buddha's void is the universe attempting to correct this anomaly. When we apply the metaphor of a living organism undergoing terminal decay, we must understand the mechanics of this necrosis. The void is not a chaotic, destructive force. It is the purest expression of thermodynamic law. It is the immune response of space itself, methodically dissolving the complex, unstable structures back into a state of maximum equilibrium. Dark energy is the driving mechanism of this response. It forces the matter apart. It cools the ambient temperature. It halts the turbulent formation of stars by isolating the fuel. It smooths out the wrinkles in the fabric of space. Gravity is losing the war. For decades, the human perspective has been biased by our own physical nature. Because we are made of matter, we assume that matter is the purpose of the cosmos. We look at the vast emptiness and consider it a gap in the architecture. But the meticulous, mathematically sound observations of the Buddha's anomaly prove that our perspective is entirely inverted. Empty space is not a container for objects. Empty space is the primary substance of reality. Matter is merely a slight, temporary contamination in the vastness of nothing. This is the intellectual vertigo that astrophysicists experience when they map the coordinates of the Great Dead Zone. It is a profound psychological pivot. They realize that the universe is not a machine built to sustain light and structure. The intricate web of galaxies is just a brief, brilliant spark in the long, dark timeline of eternity. The void is not an anomaly. The void is the default state of existence. This revelation does not diminish the value of human existence, it magnifies it. The scientists staring at the structural maps of the Buddha's region understand that to be alive, to possess consciousness, and to have the capability to measure the darkness is an absolute mathematical miracle. We exist in the incredibly narrow window of time where matter is still tightly bound, where stars are still hot, and where the light can still outrun the expansion of space. We are part of the glowing contamination. The researchers run their simulations again, watching the digital rendering of the universe as it will appear hundreds of billions of years from now. They watch the voids expand. They watch the glowing filaments of the cosmic web thin out and snap. They observe the isolated galaxies drifting further and further apart until every point of light is permanently alone in its own isolated pocket of reality. They document this process with absolute objective clarity. They do not use terms of despair. They use the precise, immutable language of physics. They measure the exact rate of the fade. By analysing the pristine emptiness of the Buddha's void, humanity has uncovered the ultimate architectural trajectory of reality. The mechanisms of subtraction are perfect. The dark energy is constant. The thermodynamic laws are absolute. The machine is functioning exactly as it must, steadily pushing the cosmos toward its final, irreversible configuration of perfect, silent equilibrium. While the thermodynamic mechanisms of the great emptiness are firmly established, the physical topology of the region presents a profound, unresolved paradox. The shape of the Buddha's void defies the chaotic, violent nature of cosmic evolution. When astronomers utilize deep space surveys to measure the internal dimensions of standard cosmic voids, they consistently find irregular, jagged boundaries. Normal voids resemble fractured caverns or overlapping soap bubbles. They are heavily scarred by the chaotic, asymmetrical mergers that formed them. The Buddha's anomaly is fundamentally different. It is shockingly, beautifully spherical. To clear a volume of space 330 million light-years wide into a near-perfect sphere requires a geometric symmetry that nature rarely produces on a macroscopic scale. In the turbulent environment of the cosmic web, random gravitational variations and the uneven distribution of dark matter should inevitably warp the edges of any expanding void. The gravitational pull from a neighbouring galaxy supercluster should distort the boundary, stretching the emptiness into an oval or a flattened disk. Yet the maps generated by our most sophisticated observatories reveal a boundary that curves with impossible precision. The scientists sit in their laboratories, projecting these three-dimensional maps into the centre of the room. They analyse the spherical geometry with a deep, consuming fascination. A perfect sphere suggests a singular, colossal event of outward pressure, radiating equally in all directions from a precise central coordinate. Standard cosmological models, which rely on the slow accumulation of smaller voids, cannot easily account for this flawless architecture. The sheer perfection of the shape suggests that our understanding of the universe is missing a crucial, monumental variable. This geometric mystery leads theoretical physicists to look past the visible matter and dive into the invisible rivers of quantum particles. We intuitively classify the void as empty because it lacks the hydrogen and helium required to forge stars. But in the rigorous realm of particle physics, the void is not empty at all. It is a raging, invisible ocean of ghost particles. Trillions of neutrinos flood the Bhuta's region every single second. Neutrinos are subatomic particles forged in the nuclear furnaces of stars and the violent detonations of supernovae. They possess almost zero mass and carry no electrical charge. Because they do not interact with electromagnetic forces, they pass through solid matter completely undisturbed. As you listen to this, billions of neutrinos from the distant cosmos are passing through your body without leaving a single trace. In the dense filaments of the cosmic web, neutrinos occasionally collide with the dense cores of stars or the packed gas of nebulae. But inside the immense spherical vacuum of the Bhuta's anomaly, there is absolutely nothing to impede their journey. The void acts as a flawless, frictionless highway for these ghost particles. If the human eye were capable of perceiving neutrino radiation, the void would not appear dark. It would be blindingly bright, glowing with the concentrated kinetic echoes of dying stars from the furthest edges of reality. To capture this invisible data, human ingenuity has constructed observatories unlike anything else on the planet. Deep beneath the glacial ice of the Antarctic continent, researchers drill vertical shafts thousands of feet into the frozen darkness. They lower strings of highly sensitive optical sensors into the pristine, lightless depths of the ice sheet. They do not look up at the sky. They look down into the frozen earth. They are waiting for a mathematical miracle. They wait for a single, high-energy neutrino travelling from the deepest regions of the cosmos to strike the nucleus of an oxygen atom in the ice. When this exceptionally rare collision occurs, it produces a microscopic, fleeting flash of blue radiation. The submerged sensors detect this infinitesimal spark. By measuring the angle and intensity of the flash, the physicists can calculate the exact trajectory of the ghost particle. They trace the invisible line backward, through the Earth, through the solar system, and straight across the millions of light years into the heart of the Bhuta's void. These researchers exhibit an almost monastic patience. They monitor the silent ice for years, slowly compiling a ghostly map of the universe. The data streaming from these subterranean observatories presents a thrilling new frontier. By studying the specific energy levels of the neutrinos passing through the void, scientists hope to detect the presence of entirely new forms of physics. They are searching for exotic subatomic interactions that can only occur in an environment completely devoid of standard matter. The void is no longer just an astronomical anomaly. It is the largest, most pristine particle physics laboratory in existence. The mysteries compound when the physicists apply these exotic theories to the problem of the missing dark matter. We know the invisible gravitational scaffolding has been excavated from the region, but the extreme cleanliness of the evacuation remains an unsolved puzzle. Standard dark matter is theorized to be sluggish and cold. When it's pushed by the expansive force of dark energy, it should leave behind thick, clumpy residues. The borders of the void should be muddy with lingering dark mass. Instead, the interior is swept completely clean. This pristine condition forces astrophysicists to propose radical new variants of invisible mass. They draft complex equations on their whiteboards, exploring the concept of self-interacting dark matter. They hypothesize a form of dark matter that does not merely exert gravity, but also possesses an internal repulsive force. Under normal conditions, this invisible repulsion is masked by the overwhelming gravity of the cosmic web. But inside the vastness of the Bootes anomaly, the repulsive force dominates. The dark matter particles actively repel one another, accelerating the evacuation process and sweeping the void entirely clean. The anomaly forces our finest minds to stretch the boundaries of particle physics, inventing new microscopic rules to explain a macroscopic absence. Yet, even these exotic particles struggle to fully explain the sheer scale and the perfect spherical geometry of the emptiness. To find a mechanism powerful enough to carve a flawless 330 million light-year sphere, the theoretical physics community must leap to the very edge of human comprehension. They turn to the mathematics of string theory and the concept of a multiverse. To solve the ultimate equations of gravity and quantum mechanics, modern string theory requires the universe to possess 11 dimensions. Human senses can only perceive 3 spatial dimensions and 1 dimension of time. The remaining dimensions are theorized to be curled up at microscopic scales, or they exist as vast, undetectable planes of reality. In this majestic mathematical framework, our entire observable universe is merely a single 3-dimensional membrane, floating within a higher dimensional bulk space. Imagine immense, invisible sheets of fabric drifting through a higher dimension. Cosmologists propose that these membranes can occasionally drift close to one another. If a neighbouring universe, a parallel membrane of reality, were to brush against our own, the physical consequences would be beyond catastrophic. The point of contact would release an unimaginable surge of energy. In the rigorous mathematics of membrane cosmology, such a localized collision would instantly obliterate matter at the impact zone. It would act like a cosmic snowplow, violently pushing all surrounding gas, stars, and dark matter outward from a singular central point in a perfectly spherical shockwave. Under this breathtaking theoretical framework, the Bootes void is not a consequence of internal cosmic expansion. It is an external footprint. It is a massive spherical bruise left upon the skin of our reality by a collision with another universe. The implications of this theory are staggering. It suggests that the boundary of our universe is not a closed, isolated system, but an interactive surface exposed to the infinite currents of the multiverse. The anomaly is transformed into a window. The scientists who run these high-dimensional simulations do not cower before the immensity of the concept. They lean over their keyboards, watching the digital membranes collide on their monitors. They experience the profound, quiet exhilaration of realizing that human mathematics can reach across the boundaries of our own universe to describe the unseen architecture of the multiverse. They are cartographers charting the shores of a higher dimension. Every new theory, every subterranean neutrino flash, and every mathematical model points toward the deepest, most inaccessible region of the anomaly. The geographic centre, the absolute core of the Bootes void, remains the ultimate blind spot in modern astrophysics. Our telescopes can map the massive walls of galaxies that form the perimeter. We can meticulously track the faint red light of the few, straggling stellar systems trapped in the outer layers. We can measure the thermal drop of the ancient light passing through it, but the exact geometric centre, the heart of the hollow sphere, is shrouded in pure, insurmountable distance. No straggling galaxies exist there. No ambient gas floats in the centre. It is a region of absolute, untarnished subtraction. We do not know what physics operate at the precise core of the emptiness. Some mathematical models suggest that in the absolute centre, where the gravitational influence of the universe is zero and the outward pull of the walls is perfectly balanced, the fabric of space-time itself might begin to behave differently. Without the anchoring weight of mass to hold the geometric grid steady, the quantum fluctuations that normally exist only at the subatomic level could magnify. The central core might be boiling with microscopic virtual particles popping in and out of existence, entirely undisturbed by the macroscopic laws of the cosmos. To uncover the truth of the core, humanity must continue to build. We are currently designing the next generation of space-based observatories. We are drafting the blueprints for immense gravitational wave detectors, using lasers stretched across millions of miles of orbital space. These future instruments will not look for light. They will listen to the microscopic ripples in the fabric of gravity itself. The scientists and engineers dedicating their lives to these machines are driven by a pure, unyielding curiosity. They know the void is holding secrets that will fundamentally rewrite our understanding of reality. The Bhuta's anomaly is a monumental gift to the scientific mind. It proves that our map of the universe is wonderfully incomplete. It demonstrates that nature is infinitely richer, infinitely more complex, and vastly more powerful than our current textbooks describe. The profound silence of the dead zone is not an ending. It is a persistent gravitational invitation to look deeper, to calculate further, and to stand in awe of the mechanics of the absolute dark. To step back from the microscopic quantum anomalies and the invisible theoretical centers is to finally witness the grand architecture of reality in its totality. We have dissected the individual mechanisms of the Bhuta's void. We have measured the temperature drops, mapped the deformed stragglers, and tracked the silent trajectories of ghost particles passing through the dark. But when the world's most brilliant astrophysicists layer these vast datasets perfectly over one another, a new and spectacular truth emerges from the monitors. The individual clues lock together into a massive, undeniable framework. The void is not merely a geographic location in the night sky. It is the master gear in the ultimate engine of the cosmos. When the researchers overlay the thermal maps of the draining cosmic heat with the structural maps of the crushed galactic walls, the grand synthesis of astrophysics reveals a universe operating with absolute, terrifying perfection. The phenomena we observe are not isolated events. They are perfectly synchronized components of a single, unified breath. The outward negative pressure of dark energy acts as the colossal piston. It physically sweeps the dark matter and primordial gas out of the center. This outward sweeping creates the immense gravitational hills at the borders. Those very borders then trap the ancient light, draining its heat and stretching its wavelengths. The engine is entirely self-sustaining. The expansion creates the boundary, and the boundary exacts a permanent thermodynamic toll on everything that attempts to cross it. The scientists looking at this composite image do not feel the crushing weight of insignificance. They experience the purest form of intellectual awe. They lean closer to the high-resolution displays, watching the mathematical models align with the physical observations. They trace the entire timeline of the universe in a single visual sweep. They see the seamless continuum of cosmic evolution. 13.8 billion years ago, a microscopic valley in the primordial quantum foam was frozen by the violent surge of early expansion. That infinitesimal deficit of energy was given eons to grow. It stretched and compounded, weaponized by the relentless properties of empty space, until it carved out a spherical domain 330 million light-years wide. The isolated red dwarf galaxies drifting in that deep vacuum are the ultimate, enduring witnesses to this grand transition. They watch the microscopic seed become an empire of nothingness. They survived the evacuation of their own cosmic neighborhood. They are currently burning their nuclear fuel with flawless efficiency, perfectly adapted to a region of space that has already entered the next phase of cosmic time. This synthesis fundamentally changes our perception of empty space. When we combine the deep ice neutrino data with the advanced theories of self-interacting dark matter, the illusion of a dead zone shatters entirely. The void is not a cosmic graveyard. It is a superhighway of absolute kinetic perfection. Because the void has actively swept away all standard matter, it has created the most pristine environment in the natural world. It is a region entirely free of atomic friction, free of gravitational turbulence, and free of the chaotic, violent collisions that plague the glowing filaments of the cosmic web. It allows the fundamental particles of the universe to travel in absolute, undisturbed straight lines. The void is flooded with invisible momentum. It is a masterpiece of thermodynamic efficiency. The astrophysicists realize that the cosmos is not suffering from an infection. It is undergoing a rigorous mathematical refinement. We look at the bright, chaotic spiral of our own Milky Way, with its detonating supernova and turbulent clouds of star-forming gas, and we project our biological bias onto the sky. We consider this bright turbulence to be the proper state of the universe, because it is the state that allows us to exist. But the objective data from the Botas anomaly proves that our crowded, glowing neighbourhood is actually a temporary state of high friction and intense disorder. The dense superclusters are burning immense amounts of fuel in a highly inefficient manner. They are incredibly loud, incredibly hot, and mathematically unsustainable. The great void represents the universe smoothing out its own geometry. The grand picture painted by the combined observations of our finest orbital telescopes is one of inexorable transition. Gravity, the great architect of the galaxies, is a localized force. It is incredibly powerful at short ranges, pulling dust into stars and stars into swirling cities. But dark energy is a property of the vast space itself. It is ubiquitous. It is patient. As the universe expands, the amount of dark energy increases because the total volume of space increases. Gravity has a fixed amount of mass to work with, but the outward push of the vacuum is infinitely compounding. The Botas anomaly is the undisputed proof that the void is the dominant species of space-time. The scientists sit in the quiet hum of their observatories, holding the ultimate blueprint of reality in their hands. They understand that the expanding spheres of nothingness are the true foundation of the cosmos. The magnificent, shining web of galaxies is merely a delicate lattice of frost clinging to a rapidly warming window. The frost is beautiful, but the thermodynamic reality of the window is absolute. The voids will continue to merge. They will continue to sweep the space clean. They will continue to push the luminous matter into ever thinner filaments until the structural integrity of the web finally fails. This is the climax of human observation. We have not just taken a photograph of a dark patch in the constellation of the herdsman. We have successfully reverse-engineered the fundamental destiny of the physical world. To grasp the magnitude of this achievement is to feel a profound reverence for the scientific method. We are bound to a tiny, fragile planet, orbiting a completely average star in a quiet suburb of a standard spiral galaxy. We are separated from the Botas region by an ocean of space so unimaginably vast that the light we receive today began its journey before the first complex life emerged from our earthly oceans. Yet, through the sheer power of mathematics, logic, and relentless curiosity, we have reached across that terrifying distance. We have weighed the invisible dark matter. We have measured the temperature of ancient photons. We have tracked the paths of microscopic ghost particles through solid ice. We have compiled the data, run the simulations, and forced the infinite dark to reveal its mechanical secrets. The universe is vast and uncaring, but it is deeply, beautifully rational. It follows laws that we, as tiny observers, can comprehend. When you stand under a clear night sky and look up into the deep spaces between the stars, you're no longer looking at an empty canvas. You're looking at the immense, overpressurized pistons of reality. You are looking at the invisible engines that are actively pushing the galaxies apart. You're looking at the flawless spherical domains where the laws of quantum mechanics and general relativity are merging into a perfect, frictionless silence. The realization does not induce panic. It induces a profound, stabilizing calm. The objective truth of the Buddha's void is that the universe is functioning exactly as it was designed to function. There is no malfunction. There is no catastrophic error in the code of reality. The sweeping of the cosmic floor is proceeding with mathematical precision. The ancient light is paying its thermodynamic toll. The stragglers are burning their slow, red fires in the safety of their isolation. The boundaries of the void are holding the line, expanding outward with the steady, unstoppable momentum of time itself. The great puzzle pieces of cosmology have snapped together to form an image of unimaginable scale. We now understand the relationship between the microscopic quantum seed and the macroscopic ocean of nothingness. We see how the loss of thermal energy in the background radiation maps perfectly to the gravitational mechanics of the expanding walls. We comprehend why the extreme longevity of the isolated red dwarfs is entirely dependent on their total separation from the cosmic web. The entire system is a closed loop of cause and effect, elegant and terrifying in its simplicity. Humanity stands at the pinnacle of this observational era. The scientists who dedicated their lives to mapping the anomalies, the engineers who built the crystalline lenses to capture the fading light, and the theoretical physicists who dared to calculate the dimensions of higher universes have all contributed to a singular, monumental revelation. They have proven that the darkness is not empty. The darkness is the engine. The grand synthesis leaves no room for ambiguity. The Buddha's void is not an exception to the rule of the cosmos. It is the rule. It is the ultimate baseline of physical reality, stripping away the brilliant chaotic contamination of matter to reveal the unyielding mathematics beneath. We are observing the future of the universe actively unfolding in the present. We have looked into the deepest, most inaccessible region of the night sky, and we have found the absolute truth of our own cosmic architecture. The machine is awake, it is flawless, and it is reshaping the infinite. To stand at the summit of this mountain of data is to look directly into the existential mirror of the cosmos. When the researchers finally step away from their monitors, leaving the complex tensor equations and the vast topographical maps of the Buddha's anomaly glowing in the quiet laboratories, they do not leave the void behind. The mathematics follow them out into the night. When they look up at the familiar glittering canopy of the Milky Way, their perception of reality is forever altered. They no longer see a permanent, unyielding dome of stars. They see a fleeting, magnificent thermodynamic rebellion. They see a temporary configuration of a light completely surrounded by an advancing tide of absolute dark. This profound shift in perspective is the ultimate consequence of astrophysics. The science does not merely catalogue the universe. It interrogates the very nature of human existence. For centuries, humanity has wrestled with its place in the grand architecture of reality. When we discovered that the Earth was not the centre of the solar system, and later, that our Sun was just one of hundreds of billions of stars in a single galaxy, a profound sense of insignificance began to permeate our philosophy. The sheer scale of the cosmos seemed designed to crush the human spirit. The discovery of the Buddha's void, an expanse of nothingness so colossal that it defies intuitive comprehension, could easily be interpreted as the final, devastating blow to human importance. It is a structure of deletion, a monument to the absolute indifference of the physical world. But a rigorous objective analysis of the data leads to the exact opposite conclusion. The void does not diminish us. It elevates human consciousness to a state of breathtaking cosmic significance. Consider the sheer physical improbability of our existence. We are entities forged from the heavy elements fused in the dying hearts of ancient detonating stars. The iron in our blood, the calcium in our bones, and the carbon that forms the foundation of our biology were violently ejected into the cosmic web billions of years ago. These elements drifted through the turbulent currents of interstellar space, collapsed under the unyielding pull of gravity, and formed a rocky sphere orbiting a stable, yellow dwarf star. Over eons, the basic chemistry of this planet organized itself into intricate self-replicating structures. This biological evolution culminated in a marvel of natural engineering. The human brain, a dense firing network of billions of neurons, operates with a complexity that rivals the physical structure of the galaxy itself. We are not fragile anomalies. We are the universe waking up. Through our intellect, the cosmos has developed the capacity to look back upon its own architecture. The human mind is the only known mechanism in the universe capable of holding the concept of the Buddha's void. A physical space measuring 330 million light-years across, characterized by total thermodynamic absence, can be mapped, analyzed, and completely understood within the microscopic synaptic pathways of a human observer. The grand, unfeeling physics of dark energy and cosmic expansion are entirely blind. They possess no awareness of their own scale. It is only through the crystalline lenses of our telescopes and the rigorous logic of our mathematics that the universe finally comprehends its own majesty. This brings us to the profound realization of our temporal privilege. We exist in a highly specific, exceedingly narrow window of cosmic time. Astrophysicists call this the stelliferous era. It is the golden age of starlight. We live in an epoch where the universe is old enough to have evolved complex, intelligent life, but young enough that the grand structures of the cosmic web are still intact. The light from distant superclusters can still outpace the metric expansion of space. The cosmic microwave background still glows with the faint thermal echoes of creation, providing us with the primordial blueprint of reality. We possess the exact environmental conditions necessary to read the history of the universe. But the Buddha's void proves that this window is actively closing. The trajectory of the cosmos is entirely dictated by the accelerating outward pressure of dark energy. The great voids are the ultimate blueprints for the future. As time stretches forward into the unimaginable depths of eternity, the mechanics we observe in the constellation of the herdsman will be replicated across the entirety of existence. The engine of expansion will not stop. It will not slow down. Slowly, methodically, the immense gravitational filaments that hold the galaxy clusters together will be stretched beyond their breaking point. The cosmic web will snap. Our own cosmic neighborhood is destined for a grand and violent consolidation. In approximately 4 billion years, the Milky Way will collide with our massive neighbor, the Andromeda Galaxy. Driven by localized gravity, these two great islands of stars will plunge through one another, triggering a spectacular era of star formation and gravitational chaos. Eventually, the supermassive black holes at their centers will merge, and the chaotic spiral arms will settle into a single, colossal elliptical galaxy. This unified metropolis of stars will contain everything that remains of our local gravitational group. But outside the borders of this newly forged supergalaxy, the universe will be undergoing a radical, irreversible deletion. As the outward rush of dark energy accelerates, the massive void surrounding our local group will expand at terrifying speeds. The distance between our unified galaxy and the rest of the cosmos will multiply. The neighboring superclusters, the glowing cities of the distant web, will be pushed away faster than the speed of light. They will slip quietly past the cosmic event horizon. The visual connection will be permanently severed. One by one, the distant galaxies will simply fade from our sky, like ships slipping over the curvature of a dark and boundless ocean. Tomorrow is not a destination. It is solitary confinement. Imagine a civilization born within our merged supergalaxy, hundreds of billions of years in the future. They will be brilliant, curious, and driven by the same profound need to understand their reality. They will build magnificent observatories on the frozen peaks of their worlds. They will point their powerful telescopes outward, hoping to map the grand architecture of the cosmos. They will see absolutely nothing, because the expansion of space will have pushed all other galaxies beyond the observable horizon. Their night sky will end at the edge of their own galaxy. They will look into the intergalactic medium and find a void far more absolute than Buddha's. The cosmic microwave background, the ancient light of the Big Bang, will have been stretched so far by the expansion of space that its wavelengths will become infinitely long. It will be completely undetectable. The foundational evidence of the birth of the universe will be entirely erased from the physical record. These future astronomers will formulate their cosmological models based solely on the data available to them. Without the faint light of distant galaxies to prove the universe is expanding, and without the thermal echo of creation to prove it had a beginning, they will come to a perfectly logical, yet entirely incorrect conclusion. They will deduce that their single, solitary galaxy is the entirety of the universe. They will believe that they are completely alone in an infinite static void. They will have no concept of the cosmic web. They will have no knowledge of the great expansion. The universe will have successfully hidden its own origins. This tragic future cast a brilliant, sacred light upon our present moment. The data we collect today, the rigorous maps we draw of the Botha's anomaly, and the intricate filaments of the cosmic web constitute a fleeting, irreproducible record of reality. We are the archivists of the cosmos. We are documenting the truth of the universe before the physical laws of nature permanently delete the evidence. The human endeavour of astronomy is not merely a pursuit of academic curiosity. It is an act of profound cosmic preservation. As the eons march on, the internal mechanics of our isolated supergalaxy will begin to mirror the dead zones we observe today. The vibrant, chaotic star formation will eventually cease. The interstellar gas clouds will be entirely consumed or swept away. The massive, brilliant blue stars will detonate and vanish. The sky will be inherited by the quiet, efficient survivors. Trillions of years from now, the only sources of light will be the red dwarfs, identical to the solitary stragglers currently drifting in the Botha's void. They will burn their remaining hydrogen with agonizing slowness, providing a faint, dying ember of warmth in an increasingly cold universe. But even these masters of longevity cannot defy the laws of thermodynamics forever. Eventually, their nuclear furnaces will exhaust the very last atoms of fuel. They will shrink, cool, and transition into black dwarfs. These are dense, lightless spheres of degenerate matter, utterly invisible against the backdrop of the dark. When the last star inevitably dies, the universe will enter the degenerate era. The cosmos will be populated entirely by black dwarfs, silent neutron stars, and colossal black holes. Yet, even in this era of absolute darkness, the relentless mechanics of physics will continue to operate. The black holes, the ultimate gravitational predators of the universe, are not entirely immortal. Governed by the complex intersection of quantum mechanics and general relativity, they will slowly leak microscopic amounts of energy into the void. This process, known as Hawking radiation, dictates that over unfathomable stretches of time, even the most massive black holes will slowly evaporate. They will shed their mass particle by invisible particle, shrinking steadily over timescales that require numbers with dozens of zeros to express. Finally, with a microscopic, silent flash of gamma radiation, the last black hole will dissolve into the expanding vacuum. When the final remnant of dense matter evaporates, the grand architectural project of the cosmos will be complete. The universe will have achieved perfect thermodynamic equilibrium. The temperature of space will drop to a fraction of a degree above absolute zero. The immense overlapping voids will have consumed everything. There will be no gravity left to pull matter together, because there will be no matter left to pull. There will be no light, because there will be no energy left to emit it. The entirety of reality will be a flawless, featureless ocean of infinite space, completely identical in every direction. The turbulent, violent and beautiful era of stars, galaxies and conscious observers will be reduced to a mathematically negligible blip in the endless timeline of eternity. The universe will finally rest. Confronting this ultimate physical truth does not require us to surrender to despair. It demands that we elevate our understanding of value. Meaning is not derived from permanence. Meaning is derived from the sheer, staggering improbability of our present awareness. We look at the Botha's void and we see the unyielding mechanics of the end. But we also see our own reflection. We are a species bound to a fragile biosphere, armed with nothing but mathematics, telescopes, and an insatiable desire to know the truth. We have looked into an abyss 330 million light-years wide. We have measured its temperature. We have calculated the exact force of the dark energy pushing its borders outward. We have predicted the ultimate thermodynamic fate of reality itself. The darkness does not diminish the light. The darkness provides the immense necessary canvas upon which the brief, brilliant spark of human comprehension is allowed to shine. We are the fleeting consciousness of the cosmos, awake for a single glorious moment, standing on the shores of an expanding ocean, bravely charting the depths of the encroaching dark. We look into the void, and we understand. We have traversed the immensity of the deep dark. We have mapped the frozen thermal shadows left behind by the oldest light in creation, and we have tracked the invisible ghost particles as they streak through the subterranean ice of our fragile world. We have stood at the edge of the great spherical abyss in the constellation of the herdsman, measuring the inexorable outward push of an invisible architecture. The Botha's anomaly is no longer a gap in human understanding. It is a profound, mathematically verified testament to the absolute laws of nature. By dissecting this colossal emptiness, humanity has successfully decoded the ultimate blueprint of physical reality. To internalize the sum of this knowledge is to experience a radical transformation of the human perspective. We must permanently abandon the ancient comforting illusion that the universe was built to serve as a cradle for light and matter. For the entirety of our history, we have looked up at the night sky and drawn imaginary lines between the burning stars, crafting mythologies and seeking reflections of our own importance in the scattered dust of the Milky Way. We naturally assumed that the glowing, chaotic structure of the cosmic web was the primary substance of reality. We believed that the voids were merely empty spaces waiting to be filled. But the rigorous, uncompromising data collected from the Botha's region shatters this biological bias. The void is not an absence, it is an entity. Nothingness is the heaviest, most dominant physical force in the natural world. It possesses geometry. It exerts pressure. It dictates the thermodynamic flow of energy, and it controls the ultimate destiny of every galaxy, every star, and every microscopic particle in existence. The intricate, shining metropolises of the cosmic web are not the purpose of the universe. They are a temporary, highly unstable contamination within a vast, expanding ocean of absolute dark. This realization demands a profound philosophical pivot. It requires us to look at the slow fading of the cosmos not as a tragedy, but as a masterpiece of mathematical perfection. The universe is currently operating in a state of extreme thermodynamic imbalance. The immense gravitational wells of the galaxy superclusters, the detonating supernovae, and the blinding radiation of massive black holes represent a chaotic rebellion against the fundamental laws of entropy. The cosmos is incredibly loud, fiercely hot, and violently unstable. It is burning its finite reserves of energy with reckless, spectacular abandon. But the universe, at its most fundamental level, seeks equilibrium. It desires rest. The Botha's void is the manifestation of this deep cosmic desire. It is the great equalizer. Driven by the relentless, negative pressure of dark energy, the void is actively smoothing out the chaotic wrinkles in the fabric of space-time. It pushes the dense, glowing matter apart, neutralizing the turbulent forces of gravity. It cools the primordial radiation, stretching the energetic light into a flat, cold exhaustion. It isolates the galaxies, cutting off their supply of raw materials and forcing them into a state of quiet, hyper-efficient conservation. We look at the 60 isolated red dwarf galaxies trapped inside the Botas anomaly, and we see the pioneers of the deep future. They have already survived the chaotic era of galactic collisions. They have settled into a permanent, undisturbed rhythm, burning their remaining fuel with agonizing slowness. They are the heralds of the long, dark epoch to come. They prove that the universe is not hurtling toward a violent destruction. It is meticulously, elegantly preparing for a state of perfect, eternal peace. To witness this grand transition, to truly comprehend the sheer scale of the mechanics at play, is the absolute pinnacle of human privilege. It is easy to feel entirely insignificant when confronted with a dead zone 330 million light-years wide. It is easy to look at the mathematical certainty of the expanding voids and conclude that our existence is utterly meaningless. But such despair is a failure of logic. It is a failure to recognize the absolute miracle of the observer. We are not merely fragile biological structures clinging to a spinning rock. We are a profound, localized concentration of the universe itself. The cosmos spent 13.8 billion years forging the heavy elements required to build our brains, subjected generations of stars to nuclear fusion, detonated them across the interstellar medium, and allowed their dust to coalesce around a stable yellow sun, all so that one day a sliver of the universe could open its eyes and look back at the whole. The dark energy pushes the cosmos apart, but it is completely blind. The galaxies radiate brilliant light, but they cannot see it. The Botas void governs the thermodynamic destiny of reality, but it possesses no awareness of its own majesty. Only we possess the capacity for awe. When a human astrophysicist sits in a quiet, darkened observatory, translating the invisible wavelengths of the cosmic microwave background into a visual map, they are performing an act of cosmic significance. They are capturing the memory of the universe. Within the microscopic firing synapses of the human mind, the incomprehensible vastness of a 330 million light-year abyss is condensed, modelled, and completely understood. We take the cold, unfeeling mechanics of quantum fields and relativity, and we transform them into a grand, beautiful narrative of existence. We are the sensory organs of reality. Through our mathematics, our crystalline telescope lenses, and our insatiable curiosity, the universe is finally able to comprehend its own scale. This realization imbues our present moment with a sacred, fleeting value. We exist in the exact mathematical center of the golden cosmic window. We live in the stelliferous era, the brief, brilliant flash of time where the universe is illuminated by the fires of countless stars. If we had evolved hundreds of billions of years later, the expanding voids would have pushed the neighbouring galaxies far beyond the cosmic event horizon. The night sky would be completely black. The foundational evidence of the Great Expansion would be permanently deleted from the physical record. We would have been born into a state of absolute, inescapable ignorance, but we were born exactly when we needed to be. We arrived precisely in time to witness the glowing filaments of the cosmic web before they are stretched to the breaking point. We arrived in time to capture the ancient photons from the dawn of creation before they lose the last of their thermal energy. We arrived in time to look deep into the constellation of the herdsman and uncover the mechanical truth of the end. The future of the physical world is written in the rigid, unyielding equations of thermodynamics. The great voids will continue to expand, driven by the inexorable push of dark energy. They will merge, swallowing the cosmic web, isolating every galaxy in a prison of infinite space. The stars will slowly exhaust their fuel, fading from brilliant blue to quiet yellow, and finally to a dim, dying red. Trillions of years from now, the very last red dwarf will exhaust its final atom of hydrogen. It will collapse into a cold, dense black dwarf, utterly invisible in the endless dark. The universe will enter the degenerate era, populated only by silent, lightless remnants and massive, roaming black holes. Yet even then, the relentless engine of physics will not halt. Over spans of time that defy human language, the black holes themselves will slowly evaporate. They will bleed their mass into the void through the microscopic leakage of Hawking radiation, dissolving particle by particle into the expanding vacuum. When the last black hole finally vanishes in a silent microscopic flash of energy, the universe will achieve its ultimate goal. It will reach maximum entropy. The temperature of the cosmos will hover at a fraction of a degree above absolute zero, distributed with perfect, unbroken uniformity across an infinite expanse. There will be no light. There will be no heat. There will be no gravity to pull matter together, for there will be no matter left to pull. The violent, beautiful era of stars, galaxies, and conscious observers will be reduced to an infinitesimal, mathematically negligible spark in the endless, silent corridor of deep time. The Buddha's void shows us this future not to incite fear, but to offer profound clarity. It strips away the illusions of permanence and leaves us with the stark, beautiful architecture of the truth. We are temporary custodians of the light, existing on the shores of an ever-expanding ocean of dark. We cannot stop the tide, we cannot rewrite the fundamental laws of thermodynamics, but while the light remains, we have the power to measure it. We have the capability to weigh the dark matter, to trace the invisible particles, and to build mathematical monuments to the fading stars. We look into the ultimate abyss, and we do not flinch. We document the grand transition with objective precision, capturing the majestic, mechanical breathing of the cosmos. We accept the reality of the Buddha's anomaly. We embrace the knowledge that the universe is a fluid, dynamic system, gracefully returning to a state of absolute equilibrium. The grand symphony of creation is simply playing out its final, lingering chord, echoing across the vast distances before dissolving into the perfect, unbroken silence of the void.